All right, this is just normal Pythagorean theorem. If it comes out to a whole number, yay, you just type it in the calculator, you get your answer. If it comes out to a decimal, no decimals allowed. All right, you have to use simplified radical form. Typically, coming into geometry, when you use Pythagorean theorem, you just get decimals, and what we've done in the past with Pythagorean theorem is just get decimals. That is no longer, all right? So we want exact answers here. So a squared plus b squared equals c squared. That's what Pythagorean theorem is. Make sure you can identify the hypotenuse. The hypotenuse, well, that's supposed to be a right angle, is going to always be the longest side, or the one across from the right angle. So I'm going to do 5 squared, b squared, 13 squared. And then I look at this and I'm like, okay, I can't add 5 squared and b squared, so I need to get b squared all by itself. I need to subtract 5 squared. So I can like change this to 169 and 25, or I could just say, minus 5 squared. Just make sure you don't do 13 minus 5 or you're going to get it wrong. Because 13 squared minus 5 squared is 144, and that's very different than 13 minus 5, which is 8. So you get 144 for that. Take the square root of both sides. I would always suggest like just putting it, like if you know your perfect squares, life is going to be easier. If you don't know your perfect squares, just type it into the calculator, see if it comes out as a whole number, and then you're done. If it doesn't, then you know you have to simplify the radical. So, I mean, that's pretty simple. But it asks for the perimeter, so just pay attention to what the question is asking. Because you know this side is 12, but it's not just 12 and then you're done. It's 5 plus 12 plus 5 plus 12. If you've forgotten what perimeter is, it's like, hey, I'm going to build a fence around my house. How long is that fence going to be around the perimeter of my yard? So, like, what's the distance around my yard? So the perimeter is going to be 34 because it is 12 plus 5 plus 12 plus 5. All right. And then this problem right here is kind of like, well, we did similar types of problem. Like we've already actually done this in our quadrilaterals unit right before Christmas. So it says the diagonals are 6 and 10. I think this might have been a test question actually. Find the perimeter. The diagonals are 6 and 10. The diagonals are bisected. What's that mean? Cut it after that. At least 2 of y'all knew that. Wonderful. So 6 is what this diagonal is, but it's 3 and 3. That's what matters. And when we took that test last semester, some of us were saying each one of these were 6, each one of these were 10, and then getting it wrong. But a rhombus, the diagonals are perpendicular, so it makes 4 right angles. So 3 squared plus 5 squared equals c squared. You are looking for the hypotenuse. So 3 squared and 5 squared is c squared. You add these together, you're going to get 34. Because 9 plus 25 is 34. And then you have to determine, because if you just put that into the calculator, you're going to get a decimal. You don't want a decimal. You've got to figure out, can I simplify that? So like 34 divided by x. And do this. And then you look over here, and none of these are perfect squares. You see that? And all these start to become decimals. And if you get anything below 4, just stop looking. Because nothing below 4 is going to simplify it. So, yeah, if you look at 2 and 17, neither one of those are perfect squares. So if you split that up, you can't actually get rid of the perfect square. So the numbers you're looking for are 4, 9, 16, and so on. So you're actually done at square root of 34, which it seems like a pretty big number. It seems like, oh, I could be able to simplify that, but yeah, you can't. So the square root of 34 is what c equals, or this side is, but I probably shouldn't circle that because we're not done. It then asks for the perimeter. Okay, well, how does one add square root of 34 plus square root of 34 plus square root of 34? Like 4 of those together. What would that look like? Yeah, it's perfect. It's just like adding 4 x's together. You don't, like, if you have 1 x and all the sides are x and you end up with 4 of them, you would just write 4x. It's the same idea with the square root of 34, because you're not going to turn it into a decimal. You're not going to change that at all. So you would just have 4 of those square root of 34s, because there's one here, there's one here, there's one here, and there's one here. So that means there's 4 of them. So that would be the perimeter. Okay, this one, I'm going to use my ID as a straight edge. You should do the same, or just, you know, if you want to get crazy, just draw them how you wish. So Nadia skipped 3 meters north. So Nadia is going to start down here. This is the starting point for Nadia. And I'm going to start it here because she's going to end up going north and east, if you can tell. North and east. So I want to start her right here. And she's going to go 3 meters north. So I don't want to get too crazy. We're going to go that, and we're going to say that's 3 meters. So Nadia's starting here, and she is skipping, interestingly enough, 3 meters to the north. And then from this point, she turns and goes east. Do we know what east is? Never eat soggy waffles, right? Never eat soggy waffles. Never eat soggy waffles. If you have forgotten that, you maybe learned it in like social studies at some point. I don't know. Maybe you didn't. But north, east, south, west, clockwise. And then we are going to go to east. So going 3 north, 2 east, 4 north. That's 4 to the north, and then 13 to the east, so kind of a lot to the east. We're going to say that's 13. I'm not going to be exact because I'm just going to write it on there. And then a little tiny baby 1 to the north. I'm going to put the 1 over there. All right, how far from start to finish did Nadia skip? So we've gone 3, 2, 4, 13, 1. But we have a start and we have an end. And we can now connect those because like the shortest distance between 2 points is what? Who remembers? Straight line, yeah. This is not going to make it all the way, is it? So we're going to go here and then we're going to move it. We're going to go here. So from here to here, that's a straight line. So now all these crazy lines that we've drawn, they mean nothing to us. We are going to create a triangle, a right triangle, from the start to the end. And we just need to figure out how far north and how far east we went. So we went 3 plus 4 plus 1 north. So 8 north. And then we did 2 plus 13, which is 2 things. And this actually comes out to a whole number, which is nice, but now it's just Pythagorean theorem. So like the difficult part about this is drawing the picture. But it's 8 squared plus 15 squared. When you add those together, you get 289, and if you know your perfect squares, you know that the square root of that is 17. If you don't know your perfect squares, I would suggest learning them. Alright, so that's 17. Okay, the altitude. So we've talked about the word altitude before, and I've attached it to a different word. Like, if you're in a plane and you're flying at an altitude of 30,000 feet, that's like how high you're flying, right? So the word altitude just means height. But the altitude of an isosceles trapezoid is what we're trying to find. So I'm going to put an X there. I'm going to draw that in, put an X. I'm actually going to draw 2 of these. And the altitude is always at a right angle with the base. So basically I've got a square and 2 triangles now. It's kind of what I split it up into. But the side lengths are 30, which this one's the longest one. So this is 30. And then this one's 20. And then we've got 10 and 10 right here. It's an isosceles trapezoid. So those 2 are the same length. And then we need to use Pythagorean theorem to solve for this. But in order to use Pythagorean theorem, we've got to realize what is this piece right here, which, if you guys can see, that this right here is a rectangle, so we've got 20 and 20. For just from here to here is 20, because rectangle, it's the same on both sides. And if the whole thing's 30 and this piece is 20, you can take that 10 that's left over and split it between these two sides. So 5 and 5. And then you can put these three numbers into the Pythagorean theorem. So x squared plus 5 squared equals 10 squared. And I'm going to pause my screen and give you a chance to solve that. Root 3. 25 and 3 go into 75. Just make sure you subtracted, for 1. And then the 25 simplifies into 5. So 5 squared root 3. Alright, for these little markings mean that they're the same. So 5 squared plus 5 squared equals c squared. You add these together. 25 plus 25 is 50. And then 25 goes into this, obviously. So it goes into it twice. Square root of 25, square root of 2. The 25 simplifies to a 5. And this is actually a pattern we're going to learn about tomorrow, the 5, 5, 5 root 2 pattern. But that's for another day. All right, set this one up over here. Okay, so this is how you set it up. Get rid of that on the background. Make sure in the parentheses, or in the calculator, use parentheses or you will get it wrong. This is the difference between using parentheses, which is the correct way, and the incorrect way. The numbers are drastically different. But when you subtract these, you're going to get 100, so it ultimately is 10 for the answer. All right, and then that's it. All right, since this is equilateral and this gets cut in half, it's 6 there, 12 for the hypotenuse, so 12 squared minus 6 squared is 108. Oh, this should be squared. X squared equals 108. And we need to find the perfect squares that go into 108. So y equals, yes, 36 and 3, right? So 108 divided by x, and then we click second graph. And then we're going to look on this blue side, and we're like, which one's the largest perfect square? So 4 goes into it 27 times, but if you pick 4 and 27, you have to do the whole process again with 9 and 3. So we're going to use 36 and 3. Square root of 36, square root of 3. 6 is the square root of 36. So 6 root 3 is that altitude, which this is a pattern that we're actually going to talk about on Thursday. All right. Last but not least, this one right here. So 4 squared plus 6 squared equals c squared. I want you to solve for this side, and then once you have solved for this side, solve for x. Here's my suggestion for this. You don't have to simplify this radical because that's not going to be your final answer. So I would just leave it unsimplified, but you can do it how you wish. See if you got square root of 52 there. You could have simplified it to 2 root 13, but you didn't have to. And then you just subtract. So the square root of 52 squared is 52. And then we're going to subtract 52 on both sides. And you get 12. 4 goes into 12 3 times. The square root of 4 is 2. So you split it to 4 and 3. And it becomes 2 root 3. So that is going to be your final answer. It's kind of a long process because you got to solve for this one first. And then you got to come solve for this one and get 2 root 3. And then one last thing I want to point out are these Pythagorean triples. And I would suggest that you guys learn as many of these as possible, and it's just going to make things go faster as you're solving these.